Hey, welcome back to the final part of my belt grinder build. If you haven't watched part 1 and 2, you can find links to those in the description. So last time we finished up most of the major parts for the grinder, and this time we're gonna make the last main parts to complete the table system, and there's also going to be some additional parts and a few changes and improvements, some electrical work, some finishing touches, and of course a demonstration of the finished machine and all the features. So let's get started with the last missing parts. First one is the clamping block that sits underneath the work table. You've seen me make a bunch of similar parts in the last video, so there's not too much to say about this one. It's exactly the same process, just with a slightly different shape. Now that the part is finished, I'm installing another one of these spring-loaded bolts, which will index the table at the 90 and 45 degree position. Next part is the table itself, and this has one feature that's pretty interesting, which is these T-slots. These might seem a bit overkill. You usually find these on milling machines, but I think they're gonna come in very handy for the kind of stuff I want to do with this grinder. Just like the other main plates, this is 15mm thick mild steel, and as always I start by making all the edges straight and square and facing the flat sides. Someone on Instagram gave me a great tip for reducing chatter when facing these parts. I'm actually only using one insert in this face mill, so it acts like a fly cutter and pretty much eliminates chatter in this case and produces a really nice finish. Now it's time to mill the slots, and the first operation is to make a channel that has the width of the narrow part of the T-slot, and it goes almost as deep as the final depth. Now that there's some room, I can come in with this T-slot cutter. I bought this specifically for this part, and I've never made any T-slots before, but it worked out pretty well. Even with that chip build up in the back there, it went in and through the cut without any issues. Since I wanted to include every possible option with this machine, there's another slot perpendicular to the last one, so you can position and slide stuff both along the belt and also into the belt. Putting a little chamfer on the edges on top here, and once again, this is not really a chamfering tool, this is actually a standard countersink drill bit, but I find those actually work okay for doing small chamfers. Again, I'm very happy with how the finish came out on this table, although it's a bit of a waste, since it's gonna get scratched up soon enough when it's in use. So if you're willing to spend the money, it wouldn't be a bad idea to use a different kind of steel for this that has a higher surface hardness. Now I'm drilling mounting holes for the clamping block, and I chose to provide a bunch of different mounting positions again. There's a good chance I'll never use those, but while I had this in the vise, I thought why not? It doesn't take that much longer. Here's a mildly interesting side note. After tapping all the threads, I noticed these tiny bumps on the other side, and these must have been created by the pointy end of the tabs, which really surprised me since there's still 4mm of steel left in between. You can barely even feel these with your fingers, it's mostly just a reflection of the light that even makes them visible, so I'm guessing the height of these bumps might be in the micron range. It wouldn't have been a problem either way, but I eventually used a flat stone to flatten these completely. Now with this block mounted to the table, all of the major parts are finally finished. I was teasing you with this in the last video, but this time I'm really installing it, and here you can see the indexing for the table in action. By the way, here's why I used 2 of those ball plungers with extra strong springs for the main clamping block. There's a fair bit of leverage acting on this due to the weight of the table and the fact that it's offset to the side, so you need quite a bit of pressure there in order for the table to not just drop down on its own when you release the clamp. At this point I was curious to see how accurate the indexing actually is, and turns out the repeatability is pretty good. When I unlock this and move it around and relock it, it ends up nice and square every time. Now I'm testing the same thing for the 45-degree position. I'm measuring the outside angle here, so that should show 135 degrees. And as you can see, it's not spot on, but when I kept resetting it, I landed within 0.4 degrees of the desired angle every time, which is more than adequate since the indexing is really just meant for a quick setup, and obviously the precision of this indexing method does have its limits. But if you do need the table perfectly spot on for something, you can of course always dial in that last bit using an angle gauge or a square and lock it in that position. And here I'm checking how parallel the table stays to the platen when I use the height adjustment. And again, pretty happy with that. Upon locking the clamp, I end up with a very similar gap in all positions. And while we're measuring things, here's the runout on the drive wheel that I mentioned in the last video. That's about 0.02 of a millimeter or about 1 thou of runout. So that's good enough for me. I even tried that stupid coin thing that everybody does, and I guess it passed the test, although to be completely honest this does fall over when I put it on the work table. But since I was planning to use this for work and not to build a house of cards on it, I think I can live with that. Let's go over some minor changes now. As I said last time, I eventually decided to add this round slot in the platen frame so that the angle can be locked more securely. Somehow most grinders have a half round slot for this, but I never understood why, because I don't see any reason why I would ever want to tilt the platen forward, so I'm just doing a quarter rotation here. Then I added the corresponding thread on the tool arm, and I also made this new axle pin here, which eliminates play where the frame rotates, as opposed to the screw that was in there before. And I came up with a little trick to screw this in, because I didn't want to mess up the surface with a wrench, so I just used one of my collet blocks to hold this, and that gave me something to grab onto. And now with this method of clamping, it can be locked down very solid. Another thing I mentioned is that I changed the gas spring setup to use one spring instead of two. And since this one has twice the pressure, it was pretty hard to compress this by hand. And it took me way too long to figure out that the easiest way to install it without hurting yourself is to just use a C-clamp to compress it first. Here I'm making some accessories for the work table, and I'm not going into too much detail here, but you'll see these at the end of the video. I also wanted a proper handle for the belt tracking adjustment, so I'm making a nice knurled dial here. This is another part that's pretty improvised. I just grabbed some stock and made this up as I went along. I put a hole in there that's slightly undersized for this screw here, and then I just pressed those two together. I wasn't sure if this was gonna work, but it actually went in nice and straight, and it seems like it's not going anywhere. So this part only took about 30 minutes to make, and I really like the look and feel of it. Now let's go over some electrical stuff. This is the VFD I'm going to be using. This is a Fuji electric VFD. I usually hunt for used industrial VFDs on eBay because these things are normally freaking expensive, but you can get some great deals if you're patient. So I paid less than $100 for this one. But unlike most people, I'm not going to be using the controls on the VFD itself. I wanted a proper control panel which allows me to mount the VFD out of harm's way, because they don't really like grinding dust. And I also think the controls on those aren't very nice or even safe to use. So I decided to make a little external control panel, and this piece of aluminum will be the housing for it. Yeah, it's a bit overkill to machine something like this from a solid block, but overkill is kind of the motto here, and it's gonna look much nicer than a board box out of plastic or sheet metal. One important feature on this is the emergency stop button. If you're building a grinder, I think you should have this, because fumbling around on the VFD control panel won't cut it when shit hits the fan. Then there's the normal on-off switch, which I raised a little bit using the spacer. And I also included a little switch to put it in reverse if that's ever necessary. And of course there's a potentiometer for controlling the speed. I didn't go over all this wiring here in detail because it's probably a bit boring for most people and not exactly my area of expertise anyway. So I was pretty happy to even get the controls working at all. This isn't my machine here, but somebody who has a shop in the same building actually has a small CNC router and helped me to put some engravings on this thing. The control box is going to attach to the base and the cable will go through the base, so that's what these holes are for. And I can already hear the armchair safety officers telling me I shouldn't put cables through metal parts like this, But look, this is only the control cable, not the power cable. So there's only 10 volts going through this, which nobody's going to get electrocuted by. Worst case is that the controls stop working. And I also made extra sure to deburr the hell out of all of these holes, so there's no sharp edges. I'm actually putting my pinky on the line here to prove this to you. And I also used a pretty sturdy cable, but I bet somebody's gonna have a problem with this anyway. Now that the base is completely done, I can paint it. The rest of the steel will be cold blued, but for the base I figured painting makes more sense. And this part of the shop is pretty dark, so that's why I'm using my camera light there. Alright, we're getting pretty close to running this beast, but before I need to take everything apart once more to do the final surface treatment. I thought pretty long about what I want to do with the bare steel. I knew I don't want to paint it, but leaving it bare also didn't seem right. So I eventually decided to cold glue everything and then apply additional rust protection to hopefully get a nice industrial looking finish that is at least somewhat low maintenance. What cold bluing liquid essentially does is to create a chemical reaction using acid, which turns steel into a black color, and this only works on steel and not on all kinds of steel either. For example, you can't cold blue stainless or chromoly steel. It provides a little bit of rust protection, but it's mostly cosmetic. There are some other methods of bluing, like hot bluing, which creates black oxide. And that's also why cold bluing is sometimes called fake bluing, but as you can tell, this whole topic is a bit of a rabbit hole. I just wanted to make clear that what's happening here doesn't have anything to do with paint. Cold blue can be pretty tricky to apply if you want to end up with a uniform surface, and I played around a bit with this until I came up with this process you see me doing here, which consists of first brushing on a few layers and then lightly sanding it with Scotch-Brite and then wiping on another 1 or 2 layers, and that ended up giving me this pretty dark and even finish. Just in case you're confused why this process is called bluing even though it turns stuff black and not blue, we're in the same boat because it makes no sense to me either. The rust protection just from cold blue alone isn't great, so I'm treating everything with this special oil now. I've had good experiences with this stuff in the past. It's a special penetrating oil that prevents or fixes rust in place. And the best thing is that this air dries, so after 24 hours it's dry to the touch and it won't rub off or attract dirt. And if it's necessary, you can always reapply it. Before I can do the final assembly, I need to install the control box, so that means routing the cable through the base, and this took a lot longer than I like to admit, but I eventually got it through and I did manage to not cut open the cable, as far as I can tell. Now all the control cables can get wired to the VFD, and then I had to set up a bunch of parameters in the menu so that those work correctly, and I also added this bend protection where the cable comes out of the base. And with that, everything is ready for the final assembly, and then we can at last make some sparks. For anyone who's still here after that dramatic display, I'm now going to show you some of the features in detail. First of all, we've got the control box with the on-off switch and of course the speed control. The VFD is mounted about 3 meters away from the rest up on the wall, so it should be far enough from the grinding dust. Then there is the forward and reverse switch, which can be engaged while the grinder is running, but you should actually flip the belt around if it's running in reverse. And then of course there's the panic button, which stops the machine and also locks into place, so you have to first twist it in order to get it running again. And here's the belt tracking in action, pretty responsive and easy to use. And I'm going to do a few belt changes now, which are quick and easy thanks to the locking mechanism. Here's some more examples for the table adjustments. So the table can slide left and right, and you can also flip it around and mount it the other way. For example, if you need the slots in a different position. Of course, you can also slide it in and out a fair bit, and this mainly comes into play when you tilt the platen. If you tilt the table and then rotate the main rod and clamp it in between, you can actually achieve compound angles. And to really get the most use out of this adjustment here, we need to put the grinder into horizontal mode. So here's how that works once again, and this time with everything installed, the grinder also stays vertical when you unlock it, which is why the pin only needs to engage in horizontal mode. So when you're in horizontal mode, there's a few ways to set up the table. If you don't need the entire belt and just want to do a quick setup, you can just slide the table all the way to the left, and that way you get about 60% of the platen surface to use. But if you really need the entire length, that's where this feature comes into play. You just flip this part around and then the table can be installed from the other side, and that way you can use the entire platen surface to grind. And then you can use the height adjustment to make sure the belt doesn't just get worn out in one area. And of course you can also still change the angle on the table. Of course you can also still change the belts in this mode. It works exactly the same way, and so does the tracking. So someone asked me if the table setup is rigid enough, and since the system is so flexible, you can actually set it up in some pretty impractical ways, which I'm doing here just to demonstrate how sturdy everything is. I'm putting my rotary table on the table here. I'm not sure how much that thing weighs, but it's heavier than anything I would ever reasonably try grinding with this thing, and even with the table extended all the way out, it can handle that without any issues. Now let's try out the platen angle adjustment. One thing that's cool about having both the platen and the table adjustable is that you can combine the angles on both of them, and that allows you to grind some very flat angles which can be quite useful. For example, you need a very flat miter cut, since most saws can usually do 45 degrees max. Last but not least, there's the table accessories. There's two different ways of using the table slots. One is to attach things to these simple rectangular guides, which only engage in the top portion of the slot, and that allows you to just drop in or take out accessories from the top and just use the slot as a guide to slide things in a straight line. But you can also use these T-nuts or T-bars, which have different mounting options, and you can attach all kinds of stuff to these using an M5 screw. And with these, when you tighten the screw, everything locks into place solid. So you can attach things to the table in different positions and lock them into place. I also made some of these little thumb screws, which can help to lock down stuff quickly without having to use any tools. And here's another use for the T-bar. I made some little spacers that go over the screws, and using these you can turn the table into a simple radius jig to grind roundovers on stuff. This is kind of a bad example with this odd shaped piece of scrap, but you get the idea. And here's a slightly better example. Since the square can be either used locked down or as a sliding attachment, it's super helpful to square things up on the grinder because it can both push material into the belt or slide it along the belt at a 90-degree angle. So for example, that's helpful if you want to get the edge on a large workpiece like this to be straight or square. And if you need the slot closer to the belt for that, you can just flip the table around. When I machined this thing, I made extra sure that all the sides are perfectly square, and that's really handy because that way I don't need a square at the grinder. I can always just use this thing if I want to square the table to the platen. And using this method I can actually make sure that everything is square on two different planes at once. Here's a little practical example. I got this odd-shaped scrap piece here, and after just 5 minutes of grinding I managed to get this perfectly flat and square on all sides, and also put a nice chamfer on the edges. You saw me do a lot of similar stuff on the mill throughout these videos, and doing the same thing there would have taken at least 10 times as long. Of course I can't grind things to accurate dimensions with this, but just being able to get a workpiece square and flat within a matter of minutes is going to be extremely useful for the stuff I do in the shop. I could go on and on showing you more about this machine, but I think you got a good overview of what it can do now, and I'm sure you'll see this get used a lot in my future builds. But for now I'm gonna conclude this little trilogy. If you like this content, you can of course like and subscribe, or even support me on Patreon, which allows me to spend more time in the shop. And as always, thanks for watching and see you next time.